All right, so for water displacement on the bottom of page 4, our first step that we're going to write down is fill a graduated cylinder. I'm going to abbreviate it as grad sil. So that means graduated cylinder, one of these things. Fill a graduated cylinder with some water. The requirement is that it's more than like what would cover the bottom of the objects or the top of the objects, but less than the maximum amount that it can hold. You don't want your initial or your final volume to be pushing the limits of how much the graduated cylinder can hold, because then your reading isn't going to be very accurate. So some water, just basically somewhere in the middle. I'm going to say like maybe half. Okay, your second step is going to be read the graduated cylinder. So read initial volume. So your initial volume is going to be the volume without the object in the graduated cylinder. So this one would be initial. Your third step is going to be put your irregularly shaped, IRREGULARL, irregularly shaped object into the graduated cylinder. Fourth step, read the final volume. So final volume would be this, after your object is in it. And then finally, one of the more important steps, or they're all important, I guess. Number 5 is going to be subtract. And so your object volume is equal to your your final volume minus your initial volume. So object volume is going to be final volume minus initial volume. If you get those flip-flopped, you would end up with a negative number, and that should be a hint that you did it backwards, because there's no such thing as negative volume. Since volume is the amount of space that something takes up, it's always going to give you a positive number. And the other piece is that for the most part in this class, volume is going to be measured in milliliters. So it would tell you when your graduated cylinder, but just keep in mind. So volume in milliliters, usually. And then, of course, every single time we're reading glassware or graduated cylinders, we're reading to the correct number of significant figures. So that concept that we learned up here, where you're going to estimate to the next place past the point of measure. So let's practice with this. We will, one of the common misconceptions that I see with students is they'll look at this and try to look at like where the height of the object is. At no point does it talk about height. Graduated cylinders aren't measuring height. We're measuring volume. We're seeing how much space it takes up. So we're measuring the water level no matter what. It does not matter how tall the object is within your graduated cylinder. So if I'm looking at this one, I see the bottom of my meniscus is like right here. This is my initial measurement before the object is in it, and then after the object goes in, my water level goes up, and that would be my final volume reading there. So based on the number of markings on my glassware, this looks like 15, 16, 17, 18, 19 milliliters, and there is a line for 19. I can definitively say it's between 18 and 20. So one place past the point of measure would mean, since it's marked to the ones, I'm going to estimate to the tens place in decimal places. So I would say that I read this as 19.0 milliliters. If you want to be super, super precise and say like, oh, I think it was 18.9, that's totally fine as long as you are giving an appropriate reading for that water level. So 19.0 milliliters. And then obviously, since you're using the same graduated cylinder, your number of significant figures that you're reading to is going to be the same for this one. So if I used 1 decimal place here, I'm also going to use 1 decimal place here. And my final answer, since I'm using subtraction, is also going to have just 1 decimal place to keep consistent with our significant figures rules. So then this one, this looks like 25, 26, 27, 28, 29. So to me, this looks like it's pretty much right on the line for 29 milliliters. So I'm going to call it 29.0 milliliters. So then if we're showing our work, my object volume is going to be taken by my final volume of 29.0 minus 19.0. Most of you can probably do that in your head, but if you can't, you can use a calculator. My warning is just that your calculator isn't necessarily going to give you the right number of significant figures, so make sure that you're paying attention. What I mean by that is that if you type in, let me turn the lamp off, see if that helps. Okay. If you type in 29.0 minus 19.0, your calculator is going to tell you 10, which is great, but if you just write 10 as your answer, that does not have the correct number of decimal places or significant figures that we need for this answer. So for this one, I would say 10.0 milliliters. Put the lamp back on so that it looks better. Cool. And then I want to pause for just a second to allow you to practice on this. So you're getting the ring volume. I want to know what is the volume of your ring, and then you can assume that both of those are given to you in milliliters. So I'm going to pause for a second and walk around to help. Okay, picking up on the ring example, going around, it looked like most of you guys were able to read the graduated cylinders very well. So if you're reading this at 60, 65, and 70, so this would be 61, 62, 63, 64. So if you think this is exactly on the line for 64, I would say 64.0 milliliters. And then on this one, I did see several students make this mistake that I was talking about of reading it by the height. You are not looking at how high in here or how tall your object is. It does not matter because we're measuring, like in 3-dimensional space, how much space it takes up. So we don't care at all where the object stops. We care where the water goes because this is displacing that much water. So if this is where my line is, I think that's the bottom of the meniscus, this is 65, 66, 67, 68 milliliters. But again, one place past the point of measure would tell me 0.0. So then you need to take your final measurement minus your initial measurement, so 68.0 minus 64.0, and then I agree with most of you guys who got 4.0 milliliters. Some of you measured 5 milliliters for this, and if you did that, I would say just double check your lines. Make sure that you actually read your initial and final volumes correctly. It could be as simple as you just looked at the wrong thing or counted incorrectly or something like that. Simple enough? All right, let's flip over to the next page and we'll start there.